Good morning. How are you doing? Coda, right, is your name. Oh, first of all, I'll just turn off my camera because it just makes it easier when I'm writing, the lag and everything. So, in the problem, right, it says that the particle starts from rest at times t equals zero, and then it moves with the position function, right, that's been given there. So, and then it asks, so the first question is what time does the particle change direction? So, Coda, with calculus, it's always important to think about the concept that the problem is asking you. So, this problem, the main concept or what it really means is what time is v of t equals to zero? Because since the velocity is the derivative of this position function, then when it's equal to zero is when, so for example, if this is the if this is the velocity graph, right? No, sorry, if this is the position graph, let's say x of t, then the velocity graph, right? It would be something like this because right, since velocity is the rate of change, right? And then at this point here, corresponding to this x value is where the particle will change direction because velocity is a has a sign, right? So okay, and that's just the concept that we'll be using here. So going back to our regular calculus, right? Since we know velocity is the derivative, why don't we find the derivative then? So derivative of t to the fourth minus t squared divided by 2 should be 4t to the third minus, and then and then the t, and then the t sorry, and then the 2 and the exponent comes down, so that would be minus t because the squared is divided by 2. So this is our function, right? Our v of t function. Okay, so in that case, right? Sorry. So in that case, right? Now we just have to find it where it is equal to 0, right? So we do 0 is equal to 4. Oh, this lag, sorry. 0 is equal to 4t to the third um minus t, right? All right. So hold on, let me just see something. Okay, so then if we do that, right? If we so we can change it and make it t is equal to 4t to the third, right? Bringing the t to that side. Now, um okay, yeah. So yeah, all right. So you know what, actually we could do that, but I think maybe what we'd want to do is this. We would just fact factor out the t. So once we factor out the t, which I'm sure you've done before, it's t 4t um squared squared minus 1. Okay, so if we do that, right? Now the thing is, right, one of the values that make v of t that make v of t equals to 0 is 0 itself, because if you do 0 times, yeah, because 0 since it's being multiplied, 0 times anything is 0, right? So t is equal to 0 is one solution. But another solution is in what's here. So we have to find, and then if we set that equal to 0, we can find the t value that would make this 0, thereby making the whole expression 0. So why don't I go to a different board? So it's remember, it's 4t squared minus 1, right, is equal to 0. All right, so if we bring the 1 to the other side, 4t squared is equal to 1. 4t squared is equal to 1. Divide the 4. So it's, sorry, this board is, so it becomes t squared is equal to 1 over 4, right? All right, so that means t is equal to um plus or minus 1 over 2, right? Because you radical the numerator, the denominator, and it's plus or minus, right? Because this is a square. If you plug it in, you can plug in negative 1/2, and it'll be equal to 0, or 1/2 itself, it would be equal to 0. All right. So that answers. So at this time, it changes direction. So and then it says, and then it says, and also t is equal to 0, but we'll probably use this one. And then it says, what's the particle acceleration at the time found in part A? All right. Well, what's the concept with acceleration, right? Well, acceleration is the derivative of velocity, right? So if we go back to here, our velocity function is 4t to the third minus t, right? 4t to the third minus t. So we just take the derivative. So sorry, the board again. So acceleration is 12t squared minus 1, right? All right. So remember that our t is equal to 1/2. That's 1. So if we plug that in, that would be, if we plug that in, I'll just do that there. That would be 12 times 1 over 4 minus 1, which is equal to 2, right? 12 divided by 4, 3, 3 minus 1, 2. And then it would be the same thing for the negative 1/2, right? Because you're squaring it. So so 2 would be your acceleration, right? And I don't know if you have units there. I don't think you need units in this problem. But yeah, but this should basically be it. Please text me if there's any confusing part. But that's it, right? We've gone. It's, of course, our concepts are very important with calculus. So we got the velocities, the derivative function, and we got the time right here. Yeah, we got the time t is equal to 1/2, and also 0 as well. So we could also plug in 0 here. That would give us a -1 acceleration at time t is equal to 0, but we probably won't worry about the 0 because the function starts from rest there. All right. Thank you very much, and hope maybe we could have future tutoring sessions together. Okay.